In this series of videos, we're going to take a look at some basic physics concepts, and today we're going to start by taking a look at inertia. Inertia is essentially the tendency of an object to keep its current state of motion. For example, let's say we have a smooth surface here and an object A on it. If it's still, it's going to continue staying still, right? Unless we push it, pull it, or basically interrupt it in any way or fashion. This is what we call inertia of rest, because an object at rest is essentially staying at rest and wants to stay at rest. Similar to that, if we had an object moving at 10 meters per second to the right, it would actually want to keep on moving at 10 meters per second to the right forever. And this is what we call inertia of motion. However, the first case might be intuitive to you, because if you put a book on a table, it usually stays still the way it was unless you push it or something like that. But in this case, let's say I have this pen here. If I push on it, it's going to gain some velocity, but after a while, instead of keeping on moving, it's going to stop somewhere, right? Stop there. So the first one seems true enough, but the second one can't be true, right? Because eventually things stop. But I want you to focus on this term here, that I mentioned that there could be no interruptions when we're describing inertia. So that must mean that when I push this object, there must have been some kind of interruption here, right? So what happened was that in an ideal case, we would have a smooth surface, and this thing would have kept on moving at the same velocity forever. But in real life, what happens is that we don't have smooth surfaces, and friction happens. Friction is basically an interruption, and it causes this thing to slow down and eventually stop. So this feels counterintuitive because we don't usually see this often. However, one easy way to imagine this for me was to just think of outer space. If I was in outer space and I pushed an object, it would keep on moving forever because there was nothing interrupting its motion, right? So this is one example of this kind of inertia being true. Another example could be the example of you being in some kind of vehicle. Let's say you're in a car that's moving at some velocity 10 meters per second. If you have a ball in your hand, you could try throwing it up. It would go up, and after a while it would come right back on your hand, right? So let's analyze the situation. Let's say the car was over here at, I don't know, some time t. After 1 second, the car would have moved 10 meters to the right, and we would have been here, right? So if you had thrown this object here, what should have happened is you would have moved along these 10 meters, but since no one was pushing the ball, it would have gone up and went down and come and arrive somewhere behind you, right? However, if you try this inside an actual car, what would happen is it will land right back on your hand. So what's happening here? What's essentially happening is that when you were grabbing onto the ball inside the car, you were all moving with a velocity of 10 meters per second. So when you threw it up, it still had that inertia there, and it kept on moving 10 meters per second alongside you and the car. So when it went up, it kind of went up like this. And when it went down, it kind of went down like this, and eventually it reached your hand. So to you, it seemed like it just went up and down. But let's say there was someone else outside the car who saw the whole thing go down. He would have seen something like this happening. So Here we see a practical example of inertia at motion, and I hope that's enough to convince you that these two kinds of inertia do actually exist. And one last thing I would like to talk about is how we measure inertia. So in physics and really in most branches of science, we like to be able to measure things. In a similar fashion, we want to be able to measure inertia. So recall that inertia essentially means the tendency of an object wanting to keep its initial state of motion. So let's say we have two objects here. If we push these with the same amount of force, let's say this one moves and this one doesn't move. We could say that this one has more of a tendency to not move, to keep its initial state of motion, right? Because it was at rest, and even though you pushed it, it kept on staying at rest. Whereas this one couldn't stay at rest because you pushed it. So we could say that this one has more inertia and this one has less inertia. So how we measure it is essentially using the very familiar concept of mass. Let's say we have a 30 kilogram object here and a 20 kilogram object here. Now you could easily tell that pushing the 30 kilogram object is going to be harder compared to the 20 kilogram object, right? So yeah, that's how we measure inertia, with mass, essentially. Well, that's it for now, I guess.